Good morning, everyone. Today we are going to continue with the pulley, and I am going to do the combination of the pulleys. Last time we have already discussed the two types of pulley, that is single fixed pulley and the single movable pulleys. So now today we are going to discuss the combination of the pulleys. The important combination is I'm going to straight away discuss the block and the tackle system. Now what happens is in this block and the tackle system we take many number of pulleys and we put them in a block form. We have two blocks here. The first one is called the upper block, which is also your fixed block, and in this upper block it consists several pulleys. Okay, and just below this upper block you have the lower block, which is the movable, and in the lower block also it consists several pulleys. So let me just show this with the help of a simple diagram. This is a rigid support, okay, and I will take one block. This is a very rough free sketch diagram, so please ignore the diagram there and concentrate on trying to understand the concept. Suppose in this block I take 3 circles, okay, and just below that you take another block, and in this block you have, let us say, 2 circles. You have a hook here and also you have a hook here. Now this is called the upper block, or also known as the fixed block, and this is known as the lower block, or also known as the movable block. What we see here is in this upper block there are 3 pulleys, okay, there are 3 pulleys, and in the lower block there are 2 pulleys. So this is fixed to a rigid support, that's why it is called the fixed block, and this is a movable, it is lower and it is not fixed to any support, that's why it is called the movable block. Now this 5 pulleys here, we can have more than 5 pulleys, also we can have less than 5 pulleys. Now these pulleys are supported by one string. It is supported by one strand or one string, okay. Now one note you have to keep in mind, that is the number of pulleys in the lower block or the movable block is either equal to or less than the number of pulleys in the upper block. So we can write like this: number of pulleys in movable block is either equal to or less than, or we can also write like this: the number of pulleys in upper fixed block. So here you cannot have more pulleys than the upper block. Here you cannot have more pulleys in the lower block than in the upper block. So that is the main thing you have to keep in mind. Okay, both the blocks can have equal number of pulleys, that is fine. So now you will be using only one string here, one string, in order to support this lower block. So that string which we are going to use is known as the tackle. Okay, so block is this where you hold the number of the pulleys, and the tackle is the string which will pass along it. Now let me draw two situations where we have the number of pulleys also same in both the blocks. Okay, this is the first one. Now let me take the second situation. I'll draw it with the help of a diagram only. This is the upper block. Let me draw two circles or the two pulleys, and one hook is here. This is another block. Here also we have two pulleys. So if you observe here, in both the block, that is the upper and the lower block, the number of pulleys are fixed. Okay, so now what happens is, in the first case, if you see both the diagram here, I am showing the diagram here. In the first case, you have the number of pulleys is more. Here in the second case, we have the number of pulleys are same. So let me draw here separately. The second situation also. Okay, I'll do here. Now how do you stand? So in the first case, suppose this I take it as case 1. In the first case, we have the number of pulleys in the upper block is more than the number of pulleys in the lower block. So now what happens is, we have to pass the string. So we take one end of the string and we tie it to the lower end of the lower hook of the block. See here, this is the lower hook. So we tie one end of the string, and that string you can pass either through this direction or through this direction. Let me pass through this direction. It goes like this. It passes through the first pulley, then it comes down, and it passes through the first pulley in the lower block, then it goes up, then it passes through the second pulley in the upper block, and it comes down, and it passes through the second pulley in the lower block, then it goes straight up to the top pulley in the upper block, and we have another end here. This is the free end. At this end you apply the effort. So please note this. This is very, very important. In the case 1, when the number of pulleys in the upper block is more than the number of pulleys in the lower block, you have to always attach to the lower hook. See, always attach the string to the lower hook, then go on passing over this pulley one by one. Then we come to the other free end where you apply the effort. Is that clear? So this diagram is very, very important, and you will be asked to make the diagram. Now similarly, let us go to the second case. In the second case, what we have is the number of pulleys in both the block are equal. That means there are two pulleys in the upper block and two pulleys in the lower block. So in this case, we will attach the end of the string to the upper hook. See, in the first case we had attached to the lower hook. Now we are attaching to the upper hook. So now the process is same. You first pass on to the pulley in the lower block, then you pass on to the pulley in the upper block, then you pass on like this, then it goes on, and we have the effort here. Okay, so now this is 2 points you have to keep in mind, and the load will be attached to this frame here. Okay, and here also we have the load which will be attached here. Now let us try to find the mechanical advantage and velocity ratio of block and tackle system. Let me draw this quickly so that you can understand it. I'll take the case 1 where the number of pulleys is more in the first. Let me draw 3 pulleys in the upper block, and in the lower block let me draw 2 pulleys. Okay, see, I'm just trying to explain the mechanical advantage. So here we have to attach the string to the lower block and go on passing over each pulley like this. Then this is your free end of the string. Load is supported here. Now if you observe here, the string used is 1, but it has got several strands, several parts. See, 1, 2, 3, 4, 5, 6. Each strand you have the equal tension will be acting on it. See, in each strand of the string there is a tension acting here. So these are called the strands. So now if you see here, the load is balanced by how many strands? 1, 2, 3, 4, 5. So load is balanced by 5 strands. That means 5 tension. And if you see here, effort is balanced by only 1. So now we know the mechanical advantage is very easy. Load by effort. That means load is 5 T and effort is T. So T and T cancel, the mechanical advantage will be 5. So what do we see here is the number of pulleys 1, 2, 3, 4, 5, and the mechanical advantage is also 5. So that means we can say that if there are n number of pulleys, then the mechanical advantage will be also equals to n. So n is the number of the pulleys and the mechanical advantage will also be n, 5. That means here it is 5, so mechanical advantage is 5. But sometimes due to when we consider the friction, due to the weights of the string and the pulleys, this may not be always true. The mechanical advantage may not be always equal to the number of pulleys, where small n indicates the mechanical advantage is equals to number of the pulleys. Alright, so now if you see there, this force effort is getting multiplied n times. Effort is getting multiplied n times. If you see here, a mechanical advantage is equals to load by effort, it's n. Okay, so effort is getting multiplied n times, where it will be acting as a force multiplier. That means with the less effort, it will lift more load. That means it will multiply by n times. That means the number of the pulleys. Similarly, we can also find the velocity ratio of the pulley in this case, the first case. The velocity ratio, all of you know, it is the ratio of the distance of effort to the distance of the load. So in a system of n pulleys, suppose in this block and tackle, in this case there are 5 pulleys. Let the load be moved by a distance x. Suppose the load is moved by a distance x. Let us say distance of the load is moved by the distance x. Then if you see that each segment of the string which is supporting the load, it moves, the effort moves by n number of times. Suppose it is moving by x distance, so the distance of the effort will move by, here in this case it is 1, 2, 3, 4, 5, so it moves by 5x. Otherwise, if it is n, then the distance of the effort will move by nx if there are n number of pulleys. But here the n is 5, so it is moving by 5x. So velocity ratio is also distance of the effort by distance of the load. Distance of the effort is 5x and the distance of the load is x. So therefore, we find that the velocity of the ratio will always be 5. One note you have to keep in mind, this mechanical advantage will not always be same as the number of the pulleys. It might decrease also, but the velocity ratio will always remain same, will always be equal to the number of the pulleys. Velocity ratio will always be equal to the number of pulleys, but this mechanical advantage may be less than the number of the pulleys. Okay, so now this is mostly to do with the block and tackle. It is very simple. I will solve some numericals using this block and the tackle system. You have to keep two things in mind. In the first one, when the number of pulleys is more than in the upper block, it is more than in the lower block, then you have to attach the string to the lower end. And in the second case, where I have doing here, where both have equal number of pulleys, then you have to attach at this upper end. Now let us go to these numericals in your textbook. Okay, we have numericals here, page number 68. Page number 68. Okay, we have numericals based on this block and the tackle and the pulley. Let me solve the first question. A woman draws water from a well using a fixed pulley. So let us say this is a fixed pulley. A woman is drawing water from a well using a fixed pulley. Let us say this is a bucket. Okay, in the question it is given like this. The mass of the bucket and the water together, see, the mass of the bucket and the water together is 6 kg, and the force applied by the woman, that means the effort applied by the woman, is 70 Newton. Calculate the mechanical advantage. So in order to find the mechanical advantage, a very simple formula is there. We have to use load by effort. E. Now here the load is not given, but the mass is given to you, and we know that the load or the weight is mass into gravity. So here you just have to take the mass, which is 6, into the gravity. It is given in the question. You can take the gravity as 10 meter per second square. So load is replaced by the weight, which is mass into gravity, and the effort which is applied by the woman at the other end is 70 Newton. So you apply 70 here. So it is very easy. 6 by 7. If you find it in the decimal, you will get it as 0.85. There will be no unit. So this is a simple numerical. This we have used single fixed pulley. Okay, here mechanical advantage is less than 1. That means effort is more than the load. But what is the advantage of using? It is changing the direction of effort to a convenient direction. That is all. Now we have another question. Let me do that. Question number 3. Okay, this question number 3 is given there in the textbook. If you look at this question, I'll just read this question quickly. In a block and tackle system consisting of 3 pulleys, a load of 75 kgf is raised with an effort of 25 kgf. Find number 1, the mechanical advantage, number 2, the velocity ratio, and number 3, the efficiency. So first of all, let me draw the diagram of the block and tackle. Now here it is saying that block and tackle system consisting of 3 pulleys. So we have 3 pulleys here. So we have to make a block and tackle system. So let me make a leveled diagram first. Let us draw a rigid support. Let us make this upper block which is fixed. And in the upper block you will have 2 pulleys, and in the lower block you will have only 1 pulley because the total number of pulley is 3. Okay, so now this is case 1 or case 2. This is obviously case 1 because the number of pulleys in the upper block is greater than the number of pulleys in the lower block. So in that case you have to attach the string to the lower hook. So like this, it goes, it passes through the pulley in the lower block, and you have the effort here, and the load is here. Okay, so in this question the load is also given to you. How much is the load? It is given 75 kgf, and effort is given to you 25 kgf. Now you have to find 3 things here. The first one is calculate the mechanical advantage. MA is equals to load by effort. So now load is given to you 75 and the effort is given to you 25. No need to write the unit. Mechanical advantage becomes 3. You could have also found the mechanical advantage by looking at the number of pulleys. 1, 2, 3. The number of pulleys is 3. Mechanical advantage is also 3. And number 2, calculate the velocity ratio. The velocity ratio is always given, we have just discussed now, is equal to the number of pulleys. So count the number of pulleys here, 1, 2, 3. So the velocity ratio is also 3. And number 3, you have to find the efficiency. Efficiency is also easy. The formula of efficiency is MA by VR. Mechanical advantage is also 3. Velocity is also 3. Since the efficiency we find in terms of percentage, so here we have efficiency is 100%. Like this, you have to solve other numericals. Please go on solving almost all the numericals from page number 68. If you cannot solve any of these numericals, I am going to discuss this in the next class, that is tomorrow. Okay, thank you.